Here's this one right here. One more time, I'll explain it. So this guy right here is going to be a horizontal compression. When you graph it, of course, you just start at 0 because there's no pluses or minuses, so you're not moving right or left or up or down. The 2 simply goes 1, 2, 1 across, 1, 2, 1 across, 1, 2, 1 across, 1, 2, 1 across. As I said, the only difficult or the only tricky part to this is going to be when you describe the transformation. This is going to be, because it's with X, this is going to be a horizontal. Now, everything with X is always backwards. Just think about it that way. Everything with X is always backwards. If you have to solve for X, you have to divide by 2 to get rid of the X, right? So, to move it to the other side, when you're solving for X, right, don't you have to get rid of that 2 by dividing by 2, which is the same thing as multiplying by 1/2. You multiply by 1/2 to get rid of the 2. So that is why when you're talking about X, everything's always backwards. So if you see a 2 in there, think of the opposite of 2, which is 1/2, not negative 2. The opposite, the reciprocal of 2 is 1/2. So this is going to be a horizontal. Now 1/2 is less than 1, so that means that the graph is being squished. You're squishing it, and that's why it's becoming like this. A 2 in the front of the X there has the same effect as a 2 on the outside. There's different reasons for it though. This one right here, that's a vertical stretch by a factor of 2. So you're stretching the graph, making it slimmer. The 2 on the inside though is a horizontal compression by a factor of 1/2. So you're squishing it. So both of them have the same effect. If you stretch the graph, you make it slimmer. If you compress the graph horizontally, you make it slimmer. That's why it's the same thing. It's going to look the same, but for different reasons. But the official language is that that's a horizontal compression by a factor of 1/2. Okay? Now let's do the next one. This one right here. Y equals, or f of x equals 1/2 x. Again, and as far as the slope is concerned, again, you're not going to move right or left. You're going to go 1 up, 2 across, 1 up, 2 across. That's your slope. 1 up, 2 across, 1 up, 2 across. There you go. So it's a wide graph, so you can see that something happened to it. Well, it is associated with x, so the moment it's associated with x, it's horizontal, because the word horizontal means this way, right? Vertical is up and down, horizontal side to side. So horizontal, remember it's 1/2, but think backwards too. So it's a horizontal stretch by a factor of the opposite of 1/2, 2. What's happening there is you have your V shape, and think of metal bars, and you're opening them, you're stretching them, and as you're stretching them, you're making them wider. So it's a horizontal stretch by a factor of 2. All right, that takes care of those. Those are the difficult ones, right? The horizontal I know can be tricky, so I wanted to share those there. Finally, let's put it all together. We're going to graph the last 2 that are there. This one, let me see. So this one right here, when we graph this one, we're going to go 7 units to the left. So we're going to 1, 2, 3, 4, 5, 6, 7. We're going to go 4 units up. 1, 2, 3, 4. We're going to go right here. We go -7 and +4, and then the graph is going to go downward because that's a reflection, and the slope is 5 to 1. 1, 2, 3, 4, 5 to 1. 1, 2, 3, 4, 5 to 1. So it's going to be a very, very slim V shape. Whoa, that's way off. Okay, let's go 1, 2, 3, 4, 5 to 1 right here. So it's going to be right there. Again, I don't have a straight edge, so excuse my crooked line. I hate to do it this way, but okay, anyway. So there's your graph. Again, you can see that it's a very slim absolute value. That is because of the 5. That's a vertical stretch. So the official description, this is a reflection across the x-axis, vertically stretched by a factor of 5, translated 7 units to the left, translated 4 units off. Okay, and then the next one is going to be the last one here that I'm going to work for you. Well, here I still need to cover the inequalities, right? This one, if we graph it, remember you solve for x. So this thing has two jobs here. Let's move the 9 to the other side. Let's divide by 3. And it looks like it's going to go 3 units to the right. So you're going to start right here. You're not going to go up or down because there's no graph over there. The slope is 3. So we're going to go 1, 2, 3, 1 across. 1, 2, 3, 1 across. And then the V shape is like that. The official description of this transformation, this is horizontally translated 3 units to the right. And then translated 3 units to the right, and then horizontally, remember backwards, compressed by a factor of 1/3. Compressed, horizontally compressed by a factor of 1/3. That's why it's slimmer. All right, last thing I'm going to share with you. Sorry guys, this thing's lasting longer than what I thought. This right here, the inequalities. So the last thing we're going to do is graph these guys right here. We're going to graph this one right here. We're going to go 4 to the left. 1, 2, 3, 4. 5 down. 1, 2, 3, 4, 5. Right here. The slope is 1, 1 up, 1 across, 1 up, 1 across, 1 up, 1 across. Same thing on the other side. Right here, 1 up, 1 across, 1 up, 1 across. Here's my, now notice there is no equal bar. It says greater than. Y value is greater than, greater than. It doesn't have the equal bar. If it doesn't have the equal bar, then what you're going to do is just do a dotted line, because I don't want the values to equal to that. I want it to be greater. Greater means bigger. Well, if the line is like this, you were taught in algebra that greater means above the line. If the line is like this is above the line. So if a line is like this and you're shading this way, lines like this and you're shading this way, what you're doing is you're shading all the possible values that are going to make this statement true. There's a ton of them. So you shade the area that you want to include in your solution. That's what inequalities do. So any coordinate found in this area that I'm shading in would make that statement a true statement. And that's what you're doing here, okay? So that's all it is for, oops, I'm putting a bunch of Z's here instead of erasing. Okay, so that's all you're doing here, guys. You're just going to graph the inequality, and that's where you're shading the graph. This is something from Algebra 1. I can pick any one of these graphs, and again, it doesn't matter. Let's choose this one, I guess. I'm gonna graph this one right here. So I'm gonna start at 0, 3, 1, 2, 3. Again, that 3, there's no number associated with X, so I'm not moving right or left. That 3 means go 3 units up. The negative means you're gonna reflect it down. The 1/2 is your slope. 1, 1, 2. 1, 1, 2. So there's your thing. 1, 1, 2. 1, 1, 2. There's my graph. This time it says y is greater than or equal to. Greater than or equal to means you do want to make a solid line, because I do want all the values that are equal to that absolute value. I also want the ones that are greater. Well, again, greater means above, so you're going to shade everything above on this one. If you ever have less than, guys, you're going to shade below. If it's greater than, you shade above. That is pretty much it, guys, for this video. I didn't get to explain all of these, but we'll share some of those in class tomorrow. Thank you so much. Bye-bye.